So in today's video, we're going to be talking about neural networks. Now these are one of the most exciting areas about artificial intelligence, and it's something that will be used in most of the things that you read about or even use that contain some level of AI. So neural networks are very similar to the brain, and that's what they're inspired off of. Of course, the brain is much more complex, it's bigger, and the way that the neurons interface with each other is far more complex than the mathematical approximations that we use in neural networks. But a neural network effectively is this idea that you've got stimuli going in or some sort of input, and the input is multiplied by different weights, so that represents how strong these neurons are, and then we've got an output that we want to get to. So, how does a neural network actually work? Because we've said already we have some form of input, and this is multiplied across and goes to some sort of output. But how do we represent this information? Well, let's say that we have 5 inputs, and these inputs could be anything. This could represent sensor data from a robot. It could represent pixels in a very small image. Of course, in a neural network that's using big images, there will be thousands of neurons going in. So these inputs, so 5, will need to go through to a hidden layer or an output layer. So let's say our neural network is made up of 5 neurons input, 2 neurons in the middle, and 1 neuron output. We're going to have 5 inputs, and each of these will have a weight going to the next layer. So that's going to be 5 going through to 2. So that means we have a matrix to represent this. We have a 5 by 2 matrix because that's 5 inputs, each of them having 2 weights going to all the neurons in the next layer. So when we get to our output layer, we'll pass the data through our input and this will get to our output. So now we're going to need a 2 by 1 because we've got 1 output and 2 inputs. So as you can see, a neural network is simply just matrices that represent all of the data that is going through. And in its simplest form, a neural network runs just by doing matrices multiplication. So let's say we have I inputs going out to M outputs. That's M for Mike. Now our next matrix needs to have M inputs, M for Mike, going through to N outputs, N for November. So this pretty much means that our output layer of the first matrix needs to be going through to an input layer of the same size. And our resulting output is going to be I by N for November. So that basically means that our initial inputs is going to be still the size of our resulting output, and then the output size is the size of the end nodes of output. And that's how a matrix multiplication works. So let's say we've got a neural network and we're multiplying the data across. What you might find is increasing values going through because we've got big values to start with or even just normal values to start with, and as it multiplies through and gets added using the multiplication rule, we end up with these huge numbers. So how do we stop this from happening? Well, this is where activation functions come into it. And the idea of activation functions, similar to an actual neuron, is you're reaching some sort of threshold before firing, rather than just having a constant amount of large stimuli being passed through. So we implement this using mathematical functions again, and there are a number of different activation functions that you can use for different tasks. And it's important that you go to Google essentially and find this out, and you play around with different activation functions. How does it affect your networks? And this is where experimentation really comes into the educational side of AI. So far, we have talked about passing data through a neural network and how overall it works. But how does it actually train? How is it actually useful? Well, we use something called backpropagation. And I'm not going to go into the details of backpropagation in this video because it's complex maths and there's plenty of videos out there that explain it. But we can treat it a bit like a black box when we're beginning with AI, because we essentially have libraries that you do .train, and all this .train does is it applies the backpropagation rule. And in very simple terms, it's looking at your output, seeing how far off the output is, and it's using this loss to calculate the change in weights across the network, so your network starts outputting the correct values. And this can take some time, and it also means that your data should have some sort of meaningful relationship with your outputs. Now, when training a neural network, there's a few bugs to look out for, and this can come into hyperparameter tuning. Often you will find that there is no perfect learning rate. Now, everyone will tell you to start off very small with a learning rate, So if it's too small, it will take a long time for your network to train. But at the same time, if it's too big, your network will converge too early and you'll probably get some quite poor results. This is another hyperparameter that you need to experiment with and play around with what really works and what works for your specific neural network. So typically, a learning rate of is about 0.01% is a general rule of thumb that people just use. But this is argued across the field because people just got used to using a different number. As I keep saying, experimentation is the best way to find out what is best for your model. Now, there are a number of hyperparameters that you need to consider with neural networks. This can be weight initialization, because depending on how we randomly generate the initial weights of our neural network, means that our neural network will be somewhere in the general loss landscape. So somewhere might be much closer to the best case scenario than another neural network that's randomly generated. So when we're experimenting, it's really good to play around with at least 3 to 5 neural networks and then average the performance to get a good idea of how well these parameters work. But then there's others like batch size, and that means how big the data set is as we're passing it through, because passing a data set at once can be a lot of memory for a computer. So instead we put it into batches where we just split the data set up into smaller segments and pass each segment through the network. But based on the sizes of these batches can dramatically affect how well your neural network trains. Then there's the optimization algorithms, and there's many different ones, the main which being the Adam optimizer and the stochastic gradient descent. And when you're looking at code online and you look at the different ways that they optimize, you'll find that they're using one of these. So in today's video, we spoke about neural networks, the very basics of how they work, how they train, and some hyperparameters that we should be considering. The best way to learn about neural networks is implementing them and just playing around and seeing what you can do. There's plenty of tutorials out there, especially working with things like the MNIST dataset and some really simple solved tasks that can get you into learning.